So, any questions? All right, so yeah, sorry again about yesterday's meeting, and apparently my screen share not working once I got the meeting going. Hopefully you had a chance to watch the video from the morning, and if you got any questions about that, let me know right now, for example. Otherwise, we're going to hop into Eclipse, and we'll play with some of the things that we talked about yesterday, just to get another view of them. All right. Man, this little thing over here annoys me. It shouldn't, but it does. So we'll call our project annoying box, and we'll start off with a J-frame. So I'll do a file new other and make a J-frame. And let's hop into our design window. I'm going to drop some widgets into here. So I'm going to start with an absolute layout so I can place things where I want. And I'm going to put down a button, and I'll do a text field. And I'll wait for Eclipse to get unlocked, because it's thinking. Wow. This is not my day for. This is not my week for technology, actually. I may just talk about poetry or something. Or car alarms. Alright, let's put this instance out of its misery. And well, there's what's going on. Looks like some kind of null pointer exception. Alright. Hi, welcome to CSE 222. We're going to try Eclipse for the first time. So we'll open a design page. We'll get rid of this, which is bogus. Alright, hold on a second. Let me turn off my ecosystem. And nothing but my X Window server and Zoom sucking up my CPU. One more try. Yeah, well, that's part of it. VI rarely does this, although VI can get you into all kinds of trouble on its own. But my goal in choosing Eclipse over other options was to try to not have you spend your energy learning about the IDE itself, but to be able to use it as a tool, right? As opposed to, like, you know, here's a hammer, make sure you take the 6-week training course on how to use it. So let me see if I can just delete this. So far, so good. All right, maybe we're okay now. We'll proceed with confidence. All right, so I have a J-frame. It's always got a content pane that gets created for us by Window Builder, right? And that gets added. So this thing in here that we're dropping these widgets into is a content pane. It's a J panel, okay? So here's what I'm going to do. I'm going to make a new J panel, and I'm going to drop it down inside here. This is the thing that usually really gets Window Builder upset. But seems to be working this time. Okay. So, we've got our J-frame sitting out here. We've got a content pane sitting in here. And we've got a J panel down here. Okay, this is what I'm picturing as being like our playing area. Okay, so if we were doing dots, this would be, you know, our array of 9x9 dots. And I'd like to put it inside here. Okay, so let's be fair, this would probably be closer to square. I'd like to put it inside here so that, you know, my dots aren't sitting right up at the very top of my window, right? So I can place them where I want, and maybe I can put my buttons over here where, you know, the person types in their name and they click this to restart and so on, and then have a playing field over here. Okay, now when I run this, we don't see anything over here, okay, but there is a J panel there. And what we're going to do is we're going to make our own version of a J panel like we did before. So we're going to make a new class, and we're going to call it let's call it game panel. And I'm going to say this extends J panel. And let's put a graphics method in here. Public void paint graphics G. We'll put a blue circle in the middle. Okay. And I've got all of these imports that need to be done. So I'll just point at those and say import. All right. So there's a new type of J panel called a game panel. And over here in my main J-frame, I'm going to change this. Let me call this the board. And I'm going to go into the source code and change it from a J panel to a game panel. So I'll say that's a game panel equals new game panel. People still coming in. That's good. All right. So if I run this, we've seen this before, right? We get our frame. We've got our widgets that don't do anything, and we've got a blue circle drawn, right? Now I asked to draw that circle at 50-50, and it came out over here. Why? Because we're drawing relative to, you know, the coordinates of this panel. Okay, so 50-50 is sitting right here. So this is nice because even though our game board is not, you know, sitting flush in the upper left corner, we can still think of this as being 0, 0. And all the coordinate stuff that we did yesterday and that we'll be doing down the road still works, right? So this also works nicely if we want to pick up mouse events. So let me right click, add event handler, and do mouse moved. And let's put a mouse handler in here. So I'll use arg0.getX to get the x coordinate. And the y coordinate. And I'll just print out a message in our console window saying where the mouse is. And so you'll notice that when I move the mouse around here, I'm not getting any messages. Okay, because I'm outside the panel. But as soon as I come into that panel, I start seeing my mouse messages. And I can sort of ferret out where the upper left corner is. It's pretty close to right here. And down here is about 50-50. That's where I said to draw the upper left corner of the circle. So if I'm in here and I'm doing mouse motion, but I could also, you know, just pick up clicks, I'm picking them up relative to this playing field that I've created. So I can put, you know, whatever I want to do as far as design outside of this. I can put buttons here, I can move this to the left or put it in the middle and so on, and I don't have to change my code. Okay, so this is the first recommendation. Make sure that you do this relative to the coordinates inside just a separate JPanel. Okay, which you're going to extend to a my panel so that you can create the paint method and so on. All right. So the other thing I wanted to talk about is, suppose we have, you know, this text field up here, and let's put some initial text in here saying enter your name. So when the person runs this, it says enter name, and, you know, I can type my name in here, Nick. And let's say that what we want our paint method to do is to paint the person's initial, right, in a box like above this blue circle. So I'd like to do something like g.drawString. And in this case, if my name's Nick, I want to draw the string Nick, and I want to put it at, I don't know, like 60 and 60. So when I run this, oh, it didn't make my circle. Why not? Oh, I meant 40. Because y coordinates go down. Alright, so it paints my initial above the circle. And what I'd like to be able to do is change my name in here, right, and have it paint based on the name that's in that box. The trick is that there's nothing inside this class that gives me access to this text field. Okay, so let me give this thing a better name, like name. And name is a text field. It's declared inside here. Okay. But I don't have access to that from my game panel. And this is a problem that pops up a lot. The mainframe, what we're looking at over here, this is what creates the J panel, the game panel, right? So it can get to methods and fields inside the game panel because it has access to it. It has this object board. But the board itself has no access to anything in this creator, this mainframe. So here's a trick we can do. And you do this once, say after you create the game panel. We can save the creator's identity in this created object. Okay, so I'm going to do something like this. I'm going to say board dot save parent, and I want to send the ID, right, the object that is the parent, that is me, right, which is where the keyword this comes in. So this is just a way for the board object, the game panel, to know who the parent is, so that it can get to, for example, the parent's text field called name, right, or other widgets that we might set up. And while I'm in here, I'm going to get rid of this private. I could make it protected so that the game panel could get to it, but I'm just going to leave it unspecified. Okay, so let's put a method inside our game panel for saving this. So I want an object that I can save the parent in. What type of thing is the parent? It's a mainframe. Okay, that's the class that this refers to. So I'm going to make a mainframe right, we're not really saving the identity, we're just creating something that points to that object in some sense. But I think of it as, you know, what's the identity of the thing that created us. Okay, so let's make a save method. So this is public void save parent. And it takes an argument of type mainframe, which I'll call mf. And then I'll just say parent equals mainframe. And so now, when the board is created, the mainframe calls the save parent method, identifies itself, and the save parent will take that identity of the mainframe, save it in this class variable. So now I can get to the parent and the parent's fields and methods by using this object. Alright, so instead of drawing the letter N, I want to draw the initial from that name box. So here's what I'm going to do. So string name equals parent dot, and this text field is called name, right? So name, which is a text field, and I'll call the getText method. And then I'll print out, instead of the letter N, I'll do name dot character at 0, and I'll append a empty string to it to force it to be a string instead of a character. And so now if I run this, it prints out the letter E. Why? Because that's the first letter in this box. Well, if I change this and I say my name is Nick, right? Well, it doesn't immediately redraw, right? There's nothing calling paint, but if, for example, I were to resize the window, it draws the initial of that name, which is N. Now my code is sloppy. If this is blank and I resize the window, I'm going to get an exception, right? Why am I getting an exception? Well, let's look at this. When you get these dumps, Java does not die gracefully. It dies, you know, with horrible kicking and screaming. Okay. But look at the beginning and look at the end. Okay. This is a number of exceptions. So let's go to the first exception. And it's all of this stuff. Okay. Event dispatch thread, that's not me. Okay. Event queue, that's not me. Repaint manager, that's not me. Window.java, that's not me. It's really the beginning where we see the useful information. String index out of bounds exception 0. And this is coming from the string class, which was called from game panel Java line 21. Okay, so there's my code. All of this is, you know, other code that was running when we resized the window, which caused a redraw, and then game panel called something in string, and that threw up. But let's look at line 21 in the game panel, and you'll see I'm trying to take the character at index 0. But in this case my name was empty, so there's no index 0. So, you know, you would want to be more careful in here and make sure that the name has a length bigger than 0 before you do that, and that's just a general, you know, caution. But in general, this does what we want, right? So, you know, I can make my name Zebra, and there's a Z. Okay, and it's just an example. I can get to any of the stuff inside mainframe by using this parent object that I've saved. Alright, so we spun a bunch of time this morning playing with this because all of a sudden the design layout broke, right? And, you know, the source code looks fine, but when I go to the design tab, there's nothing here. Okay, there's no components, properties, all of this is blank. Okay, we've basically crashed Window Builder. Well, I crashed Window Builder, it's not your fault. And what's happening here? Well, it's kind of a glitch, okay? So the logic was, you know, we're going to construct a board, which is a game panel, and then we're going to call that game panel and say who we are, okay? The problem is when we go to the design tab, Window Builder is going to try to show us the frame that we're going to see when our code runs. So it's going to actually try to execute some of this code. In particular, it's going to try to run the paint method inside the panel. And when it gets down here, it's going to try to get the parent's name, and the parent is going to be null. Okay, why? Because it hasn't actually constructed a mainframe and run this code and passed the identity of a mainframe to the child. So right now it looks like our design window is hosed, but we can fix this with something that's not a bad idea to have anyway, just as kind of a safety check. So we could say if parent equals null, let's just get out of here. Now it's never going to be null when we're actually running the code, but when we're playing with Window Builder, this will stop it from choking when it tries to draw the panel, and we need to convince it to try again. So let me close this out and try opening it, and we may have to, yep, there we go. Alright, so now it's working fine again. And you know, the reason that there's a blue circle here is because Window Builder's looking at the paint method and saying, oh, you know, they're going to draw a blue circle. Okay, but it was choking when it got to this part because the parent was null. So that's just the kind of details you run into sometimes with these tools. All right, so so where are we? We've got a way to hook up these widgets to stuff running inside the paint class. Let's make it so we don't have to resize the window to see the text. What we'd like to do is have this automatically update. So let's right click on the text field and look for add event handler. Well, action performed is called when you hit the enter key. So I could go into action performed, and once you hit the enter key, what do we want to do? We want to call the repaint method on the game panel, right? The game panel is just a board So let's just do board.repaint. Now it doesn't know what board is because board is declared down here. So let's just go ahead and move that declaration outside. And then down here we'll just use the previous declaration. So now board is a class variable, right? So board.repaint works. So this will work pretty well. I could change my name to Nick, and if I hit the enter key, right, it notices that. But you notice I got some gibberish there. And if I change my name to Zebra, I got some more gibberish. And if I do MMM, right? So what's happening here? What's the problem? I'm gonna have some salad while I wait for someone to answer. And if I resize, it cleans up. But if I just type and hit enter, it seems to be overwriting my old letters. Exactly, it does not call the repaint from the super class. Alright, so it's a dirty window, right? It needs to be refreshed. So in our game panel, we've got a graphics object. Let's pass that to the super constructor, the super class's paint method, and run this. Alright, so now it's nice and clean. And resizing, of course, still works. All right. Call the super paint in the beginning. Okay, here I'm setting the color to blue, and then I'm calling the super class's paint method. Well, part of what that does is reset the color, the default foreground color, to black. So now when I paint, my oval and my letter are coming out in black, right? So so do the super classes paint first, and then do all of your own stuff. Okay, well, it's a drag to have to hit the enter key for this to take effect. Really, we only want to do something when the first initial changes. So let's add a different handler. Let's do a key, and let's do key typed. And inside here, we're going to be here every time that a key is typed. So we could check to see if this was the first letter of the name, and if it was the same as the previous name, and if it was, we could call the repaint method, and so on and so forth. But that's way too much work, okay? Especially on a sunny Friday. So what am I going to do in here? I'm just going to call the repaint method. Maybe I need to, maybe I don't. I know that sometimes I'm going to need to. Not always, but you know, I'm just going to call it every time that anybody types anything in this window. So if I hit a backspace, it's repainting. That doesn't bother me. But as soon as I start typing, right, it's going to do that. And now I've got a bigger bug, because if I go back all the way and I delete that first character, there's my exception again. Why? Because when I hit the backspace key, it called a key event and tried to repaint the board, and it tried to get the first character. So if we weren't compelled before, we should be compelled now. Right. And maybe I'll even do something like this. Maybe if there's no name in there, I'll just draw some question marks. And maybe I'll draw them in red. Alright, so this stuff starts to get to be really easy, right? We've got a lot of functionality now. We can type in here, and whatever we type, the first character gets displayed above the blue circle. And if we happen to have nothing in here, it immediately displays 3 question marks, and so on and so forth. Okay, and it's really just a little bit of code. Alright, so that's just an idea of some of the things we can do. Let's do a tic-tac-toe board. So suppose we were playing tic-tac-toe. I used to do tic-tac-toe assignments for this class. Alright, let's make life easier on ourselves. Let's make our J-frame nice and big. And let's make this thing 300 by 300. And let's get rid of all of this stuff. And so let's think about coordinates. This is 0. This is, it's not 300, it's actually 299, but I don't want to think too hard. So basically this line is at 100, this is at 200, this is at 100, this is at 200. And suppose we just want to draw a tic-tac-toe field. Alright, well, we've got 4 lines to draw. Now, 4 lines, 2 in each direction. You could make a for loop to do this. I could move an x variable by hundreds, going from 100 to 200, or I could just make a pair of draw line statements. If I thought I was going to extend this to like a 5 by 5 tic-tac-toe board, I'd probably do a for loop. But let's be more relaxed about it. So let's draw lines. So this line starts at x is 100, y is a 0. And it goes to x is 100, y is 300. And the next one is the same thing except x is 200 everywhere. So let's run that. We got half a tic-tac-toe board already. Alright, first horizontal line goes from 0, 100 to 300, 100. And then the next one is exactly the same, except the y-coordinate is 200 at the start and the end. So we'll change those. Run this. We got a tic-tac-toe board. So when you're playing with this stuff, right, get some graph paper if you can. That always helps. And don't be afraid to draw pictures. Okay? A simple picture like this can help you a lot down the road, right? Just sort of keeping track of where things are. And yeah, if it's a general size board, you know, this has to be like width and this has to be height and you have to do division and all this. But, you know, at least to start off, make it fixed. And for PA4, I let you make it fixed, right? It's 8 boxes, 50 each. So it's going to go 0 to 400 on each side. So let's pick up a mouse click. Okay. We're already responding to mouse movements. So let's go inside our mainframe and let's look at our mouse handler. We'll keep using mouse motion instead of clicks because mouse motion is fun. So let's comment that out and let's say find the row and column of the mouse. Alright, so this was the stuff that we talked about yesterday, right? So we're going down by row, we're going across by column, and we write row column like this, right? First index is how far we go down and then across. And for these fixed dimensions where each box is 100 by 100, the formula is row equals y over 100 and column equals x over 100. Right, where those are integers, so they're truncated. So row equals y over 100, integer column equals x over 100. So let's just print out the row and column. Right? So this is how you test your code to see if you're doing this interpretation of mouse coordinates correctly. Here's our playing field. We're in row 0, column 0. There's 0, 1. There's 0, 2. There's 1, 2. There's 2, 2. There's 1, 1. 2, 1. 2, 0. 1, 0. 0, 0. Right? So wherever you are in this region, our code now knows, you know, in this case, for example, we're down 1 row and over 1 column. And so if we wanted to draw a circle in here, we could figure out the coordinates of the upper left corner and say draw a circle. So let's just add that one embellishment and then we'll call this good for now. So let's say I'm sitting at row column. Remember our formula is the upper left corner has x coordinates 100 times column, 100 times row. So if I want to draw a circle, let's say I want to draw a 75 by 75 circle. Or let's just say 70 by 70. So I want to start 15 units in from the upper left corner. So it looks like I want to draw an oval where the x corner is 100c plus 15, the y corner is 100r plus 15, and then the width and height are 70, 70. So you would make these variables, right? But let's draw a circle in that row column. So x equals 100 times column plus 15. Integer y equals 100 times row. I don't know what it doesn't like. Times plus 15. So let's draw an oval at those xy coordinates. And I moved in 15 because I wanted my whole circle to fill a 70 by 70 box. So let's do 70, 70. But I can't draw an oval from here because I'm in my mainframe, right? So what should I do? Let's call a draw oval method in the board. Let's save the oval coordinates. So I'm just saving these things. And let's make these integers. It's an integer oval x, oval y, oval x rad, and oval y rad. And these have to be integers. All right, and then down here, after drawing the board, let's just draw the saved oval. So G draw oval, let's do oval X, oval Y, oval X rad, oval Y rad. All right, so you got the connection here. What did I do wrong here? Save oval X Y. Save oval. Why doesn't it like that? Because I didn't save it. Okay. So when we get a mouse event, we probably should have just passed the XY to the game panel and had the game panel figure out this stuff, but I didn't want to move the code. So so we're going to figure out the XY coordinates where we should draw a circle and the radius, and we're going to pass that to a save function in the game panel, which will save those in these variables. And then when we call repaint, eventually a paint method will be called, and the paint method will pick up those saved variables and draw an oval there. All right, never tried this before. Let's see what happens. So, right, anywhere in the corresponding square region, it draws our mark, you know, centered in that spot, no matter where we are in there. So this is just an example of doing those coordinate transformations, right? Being able to move from an absolute XY to a particular row and column, and if you're inside a particular row and column, figuring out what the coordinates are of the corners. For PA4, it just means drawing one of these 4 lines. But if we wanted to do something different, if we wanted to draw an initial, right, we could locate the center of the box would be 100C plus 25, 100R plus 25. So maybe we use that for where we draw the initial using drawstring, right? So it's about being able to switch from one coordinate system to another. And it's not a lot of code, but you know, it's obviously code that one can get tangled up in. And if you're getting lost by this kind of stuff or this kind of stuff, right, go back to pictures. go back to that sheet that I posted that shows coordinate transformations and draw pictures of what it is you're trying to paint or interact with, and put equations on those pictures, link them together logically, and then write the code from that logic. Okay, don't try to just figure out, well, Nick did divide by 100, so maybe I'll divide by 50, right? Don't go that path. Try to understand from the ground up where this stuff comes from, right? Write it yourself and then put it in here and test it as you go, right? It's more satisfying to get little results along the way, and if you're doing something wrong, it stops you from going too far down that path. All right, so I also talked a little about the Java documentation in class this morning, and I'll just give you a really brief preview. So I've been asking you to put comments in the beginning of your classes and in the beginning of your methods. So if you're in Eclipse and you go to the beginning of a method, and instead of typing a comment block that starts with a /*, type a slash followed by 2 stars and hit enter, and it will create the beginning of a comment block for you. And so I can say in here, for example, save information on the circle we should draw based on mouse position and finding the nearest row column, right, which probably had meaning to someone. But then it fills in, these lines that say @param. So these are tags that we can use. @param says there's a parameter called xval. So I can just add a description of this afterwards. So what is xval? X coordinate of upper left corner of circle. And down here I can say y coordinate of upper left corner of circle. This I believe is circle width, and this I believe is circle height. And if it returned something, it would have said @returns, and I could put a description of the return value. Okay, and in the beginning of my class, if I say /*, it gives me another comment block. It fills in my name under author, and I can say this is replacement for JPanel. Draws a tic-tac-toe board. All right, so you write this stuff as you're going through your code, but you do it with the /** notation. And now I can say project generate Java doc, and I'll just take the defaults. And I get a new folder called doc. And if I look in there, I've got a bunch of HTML files, and if I just click on index, it's the good old Java style documentation that we've been looking at from Oracle, but this is for my code. Right, here's a game panel. The author is Nick. It's replacement for JPanel. Draws a tic-tac-toe board. And I want to know what the save oval method does. I can click on that. Here's the description of save oval. And the parameters are, nicely specified here. If there's a return value, if there's exceptions, those can all be tagged and so on. So this gives you a way to stylize your documentation. You're writing the same comments that you're used to writing anyway, but by just starting out with the /** and filling in information after these tags, you get this nice stylized documentation. So this is not required, but it's something fun to play with, and it's something nice to use to build up a portfolio as you make more and more stuff in Java. All right, have a fantastic weekend. There's no class on Monday. My office hours are changing next week, so they're posted on engrcs.com/schedule, and I also posted them in an announcement. So find me in the afternoons instead of the early mornings. Have a great long weekend. I will see you next week.